Okay, here we can look at the relationship. Since now we have a way of predicting the number of moles of a gas, we can look at the relationship to the actual number of gas molecules. We're just going to do a couple examples here. So determine the volume of 4.2 times 10 to the 23 gas molecules at SATP, or at STP I mean. So remember our relationship at STP is that the volume is equal, or the moles are equal to the volume divided by 22.4 liters. That 22.4 corresponds with STP. So if I can use this number to get moles, then I can find volume. So moles is equal to the number of particles divided by Avogadro's number. So 4.2 divided by 6.02 practically. We get 0.698 moles. And then I can take that and use that to predict the volume. Can multiply both sides by 22.4 liters here. And my volume is going to be equal to 15. Hold on a second here. My pen just stopped responding there for a second. So anyways, 15.63 liters. So there I can use a number of particles to come up with a volume for that gas. Here we'll just do the opposite. We'll have 32 liters of gas, and we'll figure out how many gas particles there are. So again, our moles are equal to our volume divided by, this time we're at SATP, so we're going to use 24.8 liters. So that's 32 liters divided by 24.8 liters, which means I have, try that again, 1.29 moles of gas. So it asks for the actual number of particles. So I can use my Avogadro's relationship, that moles is equal to my number of particles divided by Avogadro's number. 1.29 is equal to the number of particles divided by 6.02 times 10 to the 23. And so my number of particles works out to be 7.77 times 10 to the 23 particles. One more example here. We'll have 20 grams of methane, and we'll put it at some random temperature and pressure, and so we'll use our overall ideal gas law here. Step one, we have 20 grams, so we have to use that to find the moles. So moles is equal to mass over molar mass in this case. 20 grams divided by methane, which would be CH4, so 12 plus 4 hydrogens, so 16 grams per mole. And I would get 1.25 moles. Finally here, because I don't have STP or SATP, I have to use PV equals nRT. And so if I have PV equals nRT, my pressure is 200 kilopascals. Equals N, which is 1.25. Now I need to be careful here. My R I have at 8.31, that's the constant. But my temperature is given in Celsius. Remember that this temperature needs to be in Kelvin. So I'm going to add 273 to that. So we get 303 Kelvin. So I'll put that in. I'm going to multiply everything out on the right first. 1.25 times 8.31 times 303. And I get 3,147. Then I'll divide both sides by 200 kilopascals. And I'll end up with a volume of 15.7 liters. So we can see in these examples how to go from a number of gas molecules to a volume if we're at STP, or the other way around, maybe we're at SATP and we're going to go from a volume to a number of particles. Or maybe we're not at either one of our special sets of conditions, maybe we're just at some random set of conditions and we can go from a mass all the way over to a volume. Either way, just standard mole calculations, just using our new formulas to find moles.